An integer is any whole number and its opposites. By opposite tunamaanisha negative numbers because integers are always positive, so opposites are negative numbers. With that definition, it's clear that integers do not include fractions, decimals, or percentages. Now let us explore how we use positive and negative integers to describe opposite situations. Positive integers represent values above or more than a reference point. That reference point is always a zero, yani the origin. So negative integers represent values below or less than the point, that's the origin. First example comes in when reading temperatures. Anything above zero is usually a positive integer, while anything below zero is always a negative integer. For example, positive 25 degrees is above zero, while negative 10 degrees Celsius is negative because it's below zero. Same concept in finance. When you have a positive amount, you can regard it as a profit or a gain. But when you have a negative amount, that is a loss or a debt. Last example is on elevation. Being above 250 meters means you are above sea level, while negative 50 meters means you are below sea level. The three examples shows us that integers can help us to show opposite situation clearly and quickly. Let's look at the basics of a number line. Look at this number line. What can you say about it? What can you say about this number line? The first thing we notice that the zero is at the center, and that zero is what we call the origin. The second thing is that the numbers to the right side of this number line, the numbers on the right side of zero are positive, but the numbers on the left side of zeros are negative. Another basic of a number line is that the distance between consecutive numbers are equal. Now, these are the basics of a number line. let's look at an example. Plot the integers -4 and +3 on a number line. I hope unajua kuchora number line. So for this example, this is our number line. Let's start with -4. For -4, and the first step will be to locate 0. 0 will be our origin. And then because it's negative, we'll move 4 units to the left. 4 units to the left because it's negative, we move to the left. Negative, we move to the left. Now to plot +3, we already located our 0 with the origin. We'll now move 3 units to the right and place a dot. We'll move to the right because it's positive. 3 units to the right, right because it's positive. It a little bit straight. So these are horizontal line, number line should be horizontal line. After this, we should estimate the origin, which should be 0. Let's suppose our origin is here. That's our origin. Now from 0, going right, we have positive integers. So we'll have here 1. We don't need to write +1 because 1 on 1 we don't need to write +1 here because it's just positive. This is 2, that's 3, that's 4, that's 5, and we have 6, and it continues that way. On the negative side, we'll start by the negative sign to illustrate that they are negative. So here we write -1, we write -2, we write -3, we write -4, we write -5, we write -6, and it continues this way. Now that's our number line. That's our number line. Now the next question is plot the following points. That's -5, +2, 0, +6, and -3. Now, how do we plot integers on our number line? Let's start with -5. Here is -5. -5, we dot -5. Yeah. And then we have +2. Here's +2 here. We have 0. 0 is our origin. Yeah. Dot it. We have +6 here. Dot it. We have -3 here. Dot it. Now we have plotted the points on our number line. The last part now is comparison. We are asked to compare, to use the symbols less than, greater than, to make the statement true. So here are the comparisons that you're expected to complete. The first one will be comparing -3 and 2. The second one will be comparing 0 and -5. -5. The third one will be comparing -5 and -3. The fourth one will be comparing 6 and -6. And the last one, the fifth one, will be comparing -1 and 0. Remember our rules. Our rules are very, very simple. The rules of comparison numbering are very, very simple. The number on the right is always larger. The number on the right is always larger. Let's note it here. Integer on the right side, the right side is always larger. Yeah, always greater. It's always greater. So -3 and 2, which one is on the right side? Yeah, 2 is here, and you have -3 here. So -3 is on the left side. So -3 is lesser than 2. 0 and -5. 0 is here, -5 is here. Which one is on the left side, on the right side? On the left side is -5, on the right side is 0. So 0 is greater because it is on the right side of the number line. Now, -5 and -3. Now we are here, -5 and -3. You can see -3 is on the right side and the -5 is on the left side. So -5 is less. -5 is lesser than -3. Now 6 and -6. This is straightforward. 6 and -6. You can see 6 is on the right side, and the integers on the right side are always greater than the integers on the left side. So 6 is greater. 6 is greater than -6. Now the last one, -1 and 0. You can see we have 0 here, we have -1 here. -1 is on the left side. -1 is on the left side. So we say -1 is less than 0. That's how we compare integers on number line. Very simple.